Welcome to homework.
Problems 9 and 10 I'm going to solve together because they look at the exact same system. In one case, or in both cases, we have a beam that is pinned at the right end, and then there is a cable that goes over a pulley that then attaches to a wall over here, and then there's an external load acting. And in problem 9, we're told to take this as 8 kilonewtons, and then we want to figure out what the normal shear and moment are at this point here. So that's 3/4 of a meter in from the pivot or the pin joint. So I'm going to actually kind of do this using vectors. You could do it either way, but I figured I'd do it this way. You could do it just by looking at components. But so I guess I took this point as my origin, and then the position of this point here is given by this vector, and this point here is given by this vector, and the position of the point of interest where we want to cut is again minus 0.75 meters that would be to the left of the origin. At the pin joint, we have two components of force unknown, and up here, what we can do, since we weren't really asked to figure out what any of the details of what's going on in this region here, we can just cut this rope right here and consider these as just internal forces that are equal and opposite, and they won't come up into our analysis. I did it with vectors because I was thinking that maybe we were going to need to look at something internally here, but it turns out we didn't. So then F2 is just this force in the horizontal direction, and F4, what's F4? I think that should be 3. I wrote the wrong number there. That's just our applied load. So then we have our internal load, and I'm going to look at the section to the right of the cut. So we have minus n minus v, and then we have minus m for our moment. We can sum forces and moments on the entire body, and that will allow us to find, let's see here, that will allow us to find F2 and F1. So it turns out F1 is minus 30 kilonewtons in the x direction, 8 kilonewtons in the y direction, and F2 is 30 kilonewtons, so that's the tension in the cable. Now we can, if we make this cut here and look at this section here, we just have F1 and then the internal reactions to consider. So we have the force balance is just F1 plus P equals 0. And then our moment balance, we have R1 cross F1, which turns out to be 0. And then RP, which is this vector here, cross FP, which is, actually I labeled that, I think I renamed that to just P, yeah. And then plus M, and that has to be 0. So we'll get 3 equations out of here, 3 non-trivial equations, and we can use those 3 equations to solve for the three unknown internal forces and moments here. And it turns out that then P, the normal force, is minus 30 kilonewtons. The shear force is 8 kilonewtons, and then the bending moment is 6 kilonewton meters. Now in problem 10, we're asked to figure out what, let's see here, what load we could apply here if this cable can only withstand 2 kilonewtons of force. So it's the exact same analysis, but now we basically have this as an unknown instead of this. So we can just go through the algebra again, same equations, just we change what we're looking for. And in that case, we find that F4y, which is this is the applied load, equals 0.267 times F2. So this is the tension in this cable. And if we set that F2 to F2 max, which is 2 kilonewtons, then we get Fy max equals 0.533 kilonewtons, which is obviously a whole lot less than what we were applying here. And in this case, because the force, the tension that this cable can withstand is much less than what it was required to withstand when we were putting 8 kilonewtons out here. Then we can go back and then figure out what the internal forces and moments are, and we get a normal force of minus 2 kilonewtons, a shear force of 0.533 kilonewtons, and a bending moment of 0.4 kilonewton meters.